Hello everyone. I'm audible. Yeah. So welcome everyone to the talk from Tensors to Clouds, Guide to Zarr Python 3. This is 23rd April, 12:25 p.m. So yeah, let's dive into it. Um, this is me, Sanket Verma. You can read about me. Among other things, I take care of the OSS and community of the Zarr project. I have been maintaining the project for the last 3.5 years now. So yeah, if you want to learn more about me, you can scan this QR code. Yeah. If you want to follow along the presentation for slides, you can go to this QR code, which will take you to the Google Slides, or you can just type this bit.ly link. I'm just gonna pause for like 5 seconds before I move on to the next slide. And there's also a notebook I've prepared for the demo session, and it's in this GitHub repository. So you can also check this out. Yeah, I'll again wait for 5 seconds. Okay, moving on. So I've divided the talk like simply into like 4 topics, which is basically the fundamentals or the 101 of Zarr. The next part would be what's new in Zarr Python 3. So as you can see, there has been versions 1 and 2, so there's 3, and there have been a lot of improvements and changes we have done in the version 3. There's going to be a Jupyter notebook with demos, with the demo, and I'll be showing that. And in the last, I'll just state how you can get involved with the project if you like this talk or if you like working with big arrays. But yeah, before I dive into like the basics, I just want to get the feel of the audience. Like, how many of you heard about this project? Oh, wow. And that's really good. And how many have you used Zarr Python 3? Okay, cool. So I think I'm in a good place. Yeah. So arrays, like, they have various dimensions for storing data sets, and we store arrays in 1D, 2D, and 3D. If your array is like small enough, it's easy to work with, easy to store in memory. But if it gets too big, it becomes too complicated to work with. And this is where basically Zarr comes in. It divides your big array into small parts, which are known as chunks, and compress those each chunk into small sizes so that the large array gets reduced into small sizes. And the retrieval works in a way that only the desired chunk will be loaded into your memory, not the entire whole array. Every chunk is assigned a key for identification and retrieval purposes, and the value is actually the data stored in it in a binary format. These graphics were kind of donated by this person, Trevor Mann, so thank you, Trevor. You can store arrays into multiple hierarchies, like a tree structure, which is essentially known as Zarr group. And this is basically how the structure looks like. The JSON format, the Zarr.json is the metadata of the array, which contains the shape of the data set, size of it, custom attributes that you can assign, and yeah, all the other things which are essential for the metadata. And this is basically the chunks which contain the actual data sets. In the demo, I'll be showing how this is stored in actual local store. So you'll have a clear image of this. This is how this looks like in an actual computer. Zarr is basically based on a specification. So there's the link for the spec website, and we have evolved over the years to version 3. Specification is just a fancy word for technical document which lays out the rules, how the project should work, the metadata strategies, the metadata format, the chunking, how the hierarchies are ordered, what type of attributes you should add, data types, and node names. I should have waited here for like 5 seconds, but if anyone wants to take a photo, they can have a look. Okay. Yeah, so I'll be talking about Zarr Python mostly, but it has implementation in all the major languages. And I think that was one of the most important goal of going to version 3 to increase the interoperability among the ecosystem. So if you're not a Python user, yeah, please try one of these, implementations in Zarr. So yeah, let's dive into the core part of the presentation, but I just want to know, is everyone with me so far? Okay, awesome. So before I dive into this, I have prepared this like one slide which basically tells about the motivation, why did we start working on the version 3? And the first reason was the interoperability. So version 2 specification was highly entangled with the Python language, and it was not easy to implement. There were implementation in the version 2, but there was not easy to implement in other languages. So that's why we shifted from version 2 to version 3 to increase the interoperability, which basically opens the door for implementation in like very fast languages like Rust, C, C++, and others. There were some issues that we were facing when working with the high latency storage, like cloud object storage, and yeah, other goal was to address those issues when working for Zarr Python 3. And the the other most important part was the extensibility, which you're going to be seeing in the upcoming slide, add is to let the community and the users add their own custom extensions like data types, chunking strategies, shape of the chunks, and how they manage their data sets. And this has played, like these three were the most important reasons why we started working on Zarr Python 3. Yeah, so yeah, so before I go, you can also do this pip install upgrade Zarr, or you can install it via Conda. That's fairly easy. And if you are looking to install the special groups which add with extra dependencies, you can go with this pip install Zarr extra, where extra equals to GPUs and remote. GPU support for Zarr is added via QPy, and remote support is added via FSPEC, which lets you write the dataset like the Zarr data to cloud storage like S3 and GCS. Yeah, so the major design updates, which is basically the highlight of this talk. So we added a new abstract base class. So earlier there was used to be a mutable mapping, which basically lets you map every chunk to a value. But we removed that in the Zarr Python 3 and added a ABC store class. The reason for adding this was to enable the users to add custom storage classes to their implementations. And this has been like super useful because people have been developing storages which were kind of similar to the Git. So think of a storage format which is similar to a version control system, and this ABC store enables that. And the other important part of adding a ABC store was that previously we had so many exotic stores like SQLite, MongoDB, and it kind of like bloated the library a lot. So we wanted to like slim the library, lean it, and make it fast and efficient. So we removed all these stores and only kept the zip store, which basically lets you zip the Zarr array into a one zip file, local store, which is directory store, and FS store, which is the remote store. The other important part was to add custom codecs via entry point mechanism. So previously there was this library numcodecs, which was like dependency for Zarr, which enabled you to use 20 compressors. And it was fine because it was not in the Zarr Python code base, but we wanted to enable users to add their codecs like in the storage. So we enabled this entry point mechanism, which enabled users to add new custom codecs, and we included the most used and important codecs into Zarr Python. So Zarr Python currently contains only BLASK, ZStandard, and gzip, and all the other codecs, they are in the num codecs, and there's Zarr, and they can utilize the entry point mechanism we have developed for the codecs. So basically, like keeping all the essential and like 3 to 4 codecs and storage into Zarr Python, and keeping everything outside, and allowing the users to add these new custom codecs and storage systems via entry point mechanisms. And also, like, we added the GPU support for Zarr. So basically, if you are on a system which has GPU and you want to load the arrays into GPU memory, you can do this via enabling the GPU command. And currently it only reads the array into GPU memory, but the encoding and decoding, it still happens on the CPU. And the next hope is to basically add the codecs, which will allow the encoding and decoding on GPU memory. Yeah, so changes and deprecations. So what changed? What changed? So I think previously there were many ways you can create Zarr, which kind of signifies the leaky abstractions of the library, and we kind of like simplified that. So if you want to create an array and group, you have to use like create array and create group. Earlier it was open and all these other things. So we boiled down to like very simple notations or how you can create arrays and groups, and the storage class was kind of like changed into Zarr.storage. And you can, so basically you have to use this Zarr.storage import local store instead of this, which was the earlier one. These are the list of the modules which have been deprecated, and there are some of them which do not have no replacement. And the mostly these packages have been moved, these functionalities have been moved to a separate package, or they have been absorbed into the current code base under different classes. I'm just going to pause here for 5 seconds so can everyone have a look. And yeah, so we also were able to get together a migration guide, which can be seen here, which lays out how you can pin your dependencies and what you need to basically make sure in order that your project doesn't break if it uses Zarr. So this graphic basically lays out the difference between the V2 and V3 arrays. As you can see, initially the metadata was kind of split into two parts, the custom attributes and Z array, but right now it's consolidated into the Zarr.json. And the arrays and the chunks are kind of like grouped together in various separate folders, which is similar for the Zarr groups as well. If you are interested in sharding codec, which I'll be showing in the demo, which is basically lets you group together many chunks into small units, shards. So let's just say if you're working with a array which has, I don't know, 100,000 chunks, it becomes super difficult to work through like cloud object storage. And this is where basically sharding comes in, because it lets you group chunk into small parts, which makes it easy to read and write across high latency storages. As I said before, extension. So the storage system that I was mentioning, which was similar to Git, this is basically ice chunk, which has enabled us to, which was basically responsible, which was basically enabled through the ABC store class. Then there is the Zarr, which is the Rust library for storage format, and the Zarr Python kind of works as a bridge between these Python implementation and the Rust implementation. So the reason that I showed the ABC store and the custom codecs, because that was the because these kind of experimentation and new things were enabled. And recently, like we have been working to add the new data types to the Zarr format, essentially the data types which are used in the AI space for storing model weights and steering data. And there have been like so many requests from the AI community and stuff. So if you are interested in helping out with that, you can read this repository, and if you are interested in adding your own extensions, you can look at that. So yeah, let's see some code. Yeah, I think it's visible, right? Is it visible in the back? Okay, cool. So yeah, as you can see, I think the recent version 3.0.7, which was released 2 days ago. So yeah, we have this. So what we are doing here is we have initialized a store, memory store. We are not storing that data into the local store because it's still in the memory. We have defined the shape of the array, which is 10,000 by 10,000 and chunks 1,000 by 1,000. And we have used data type int. So as you can see that we have this Zarr array initialized. It's C order, row major, and number of bytes are this. So earlier there used to be, so yeah, one more difference. Like earlier there used to be an info function which prints the information about the Zarr array, but it was also doing little bit of computation in the back. So we kind of split that into info and info complete. So when you do z.info, it doesn't do any computation in the back. It doesn't fetch the size of the chunk. It doesn't fetch what kind of chunks were initialized or not. But if you do info complete, it's going to show you information more than that, which is basically like the storage ratio and number of chunks which are initialized. After that, I'm writing some like scalar value to the empty array, and you can see the chunks have been initialized, like all the chunks have been initialized because I used the colon here. As I said before, like if you're working with like scientific data sets from domain like geospatial or bioimaging, you need to have some attributes to identify what type of data set you're working with, and this basically ZAtlas functions allow you to add custom attributes to your data. So if you're working with like different storages and you want to store that Zarr array into a persistent memory, and that can be moved across like various storage system, we have allowed the persistent array. And what you can do here is like, you can just add the you can just use the create function to create the array, and you add some like scalar value to it, and you can see like it's initialized over there. And there's like no need to close the array because the flushing and the closing will happen automatically. Earlier you had to explicitly mention that you are closing the array and flushing it. So that has been taken care by the library itself. As I said before, like the compressors have been like removed, like have been moved into Zarr-Python. The compressors which are in the Zarr-Python are BLOS, C standard, and gzip. And you can add multiple, like you can add the shuffle level and what kind of codec you are using this argument, and you can just create a Zarr array, and this will look something like this. And earlier we were using, I think it was BLOSK. The default is BLOSK, but we use the different shuffle level here. Yeah, so now coming to the groups. So group was basically the hierarchical structure of storing these Zarr arrays. So what I'm doing here is I've created a root, which is here. Then I have created a foo, which is another node, and in the bar I have created another node, and in the bar node I have created an array. So you can see like this will look something like this. So tree functionality is not the part of Zarr-Python, so you would need to have this rich dependency installed in order to have this diagram. Yeah, and as always, like the info and info complete will work as just as, and it will lay out the information about the members, the arrays, and groups. So another thing about the group which is new to the Zarr-Python 3 is earlier if you want to create a long group, you had to explicitly go and create array at each node. But now you can just add this notation over there, and the create hierarchy function will automatically understand that you are going to create a group with A as a first node, B as a second node, and C as a third node, and it takes care of that. And yeah, it looks something like this. We are also using the Donfig Python library to handle the configuration values of these Zarr. So the default value for creating and storing Zarr arrays row major, but if you want to change that, you can just do that using the config.set, and yeah, I'll just change it back. But if you want to enable the GPU support, you would also need to use this config.set and enable GPU. A bit about the optimizing the performance. You can slice the chunks across both the dimensions or single dimension, depending on the use case. And there was this other query about what should be the ideal chunk size when I'm creating a Zarr array. So we kind of like added this auto keyword over here, which basically chunks your entire array based on heuristics. First of all, it's not optimal because it guesses on like simple heuristics. So if you are being like super lazy, you can do that, but I would recommend, doing the chunk size on your own. Sharding, as I've seen before, as I told before, like it has this big array which chunks into like small, which chunks the array into small parts and store that big small chunks into like small shards. Here I have this like small demo which kind of convert the pixelated logo of Zarr into from PNG format to Zarr format. This was just my experimenting to see if everything is working fine in Zarr-Python. I have imported this logo and converted this logo into like NumPy array and then back to Zarr, and then to Zarr array, added some of the Z adders over here, and yeah, you can see like the logo shows back, and then we get the original picture back, and I've saved it. If I have to see, this would be something notebook data, and yeah. So this is essentially the logo in Zarr format, and these are the chunks which have been initialized, and you have the the JSON which has the attributes and everything. Yeah, so coming back to, so here are some examples of what the V3 datasets look like. Yeah, you can just see these. These are visualizers which are available on the web. NeuroGlancer is being developed by Google. There is this OME NGFF challenge, which basically was an effort to let the institutions collab on creating like large datasets in Zarr-Python V3. If you are interested in using this library and contributing, and if you have any questions, feel free to join in on like any of these office hours or meetings. There's the link for the website, and I think that's it. Thank you.
Awesome. Thank you for the talk. Very informative. Now for questions. I have 0 questions on Slido, so please, if you want to get wiser about Zarr, this is your chance. And in the meantime, I'm going to ask one, so it gives you the time to post your questions. So Zarr-Python is an open source project. Do you welcome contributions? And if so, what ways of contributions are the best for your project?
Yeah, definitely. Like, I think the answer is yes, we welcome contributions, and it's hard to say what's the best way to contribute to the project. I think like every contribution matters, like be it like technical or non-technical. So if you're using a project and if you came across an issue and which basically says that the project shouldn't be working as expected, just file an issue. And I think that's in contribution. If you see docs, if you read it, if you're going through the tutorials, and if you see something is off, you can just file an issue and edit that. If you want to get more involved and deep dive into the features and start working on some functionality, that's like the soup. That's very great. So yeah, I think like there are various ways we can contribute to the project.
Thank you. Yeah. And about the Zarr spec, I mean, I don't want to talk about V4 since V3 just came out, but is that contributions also goes for the specifications or?
Yes, contribution definitely goes to specifications. So some of the ideas which I have talked about here, like the custom storage and the custom codecs, they were originally motivated from Zarr-Python use cases. So people were coming with their requests and they were like, we should do this and that. And we realized that our spec is not that flexible to add that functionality. So we kind of like went back to the spec, made some changes, and then came back to Zarr-Python and fixed it. So I think it's like a two-way process.
Thank you. In the meantime, I'm getting questions in. So let's go with the first one. If Zarr array is still used to convert from NumPy, why did you go to create a new create array function?
I think we're talking about the notebook, right? Oh, yeah. So, yeah. So if you want to, so basically what I did here was I converted the image into the NumPy array. And then I converted the NumPy array into Zarr because there's a function which lets you convert the existing NumPy array into Zarr array. And basically what Zarr acts as is like a NumPy container. So you have a NumPy array and you have a Zarr array. The difference is like this, it's chunked, it's divided into small parts, and there's a metadata at top of it. So that's the basic difference between a NumPy and Zarr array. And there's like other things like, you know, when you have divided your array into small parts, it lets you talk with like cloud storage very easily and all that stuff. So yeah.
Great. Next question. Does Zarr V3 support usage of async I/O? Does Zarr-Python support it?
Oh yes, yeah. So Zarr-Python version, Zarr-Python 3 code base is completely asynchronous. So we have heavily used the Python async IO library. So yeah, we can use it.
Next question. What is your feeling about keeping different Zarr implementations in sync regarding extensions and such?
Oh, okay. I think this is more of like a social challenge and a technical challenge. Most of the implementations that we have under the Zarr banner, they are being maintained by researchers and academics in various institutions, and they develop features and stuff according to their need. So our recommendation is always to keep up with what Zarr-Python 3 is doing. Sorry, what Zarr-Python is doing, but it depends on the use case. So yeah, I think like it's the original motivation is to, yes, please keep up with all the extension, but it also depends on what kind of work you're doing.
We got more questions going in. Meantime, I guess we can go until 55 since
Okay.
we're out of schedule. What are the competitors in this space, and what does Zarr do that is unique compared to them?
Okay. I'm a bit uncomfortable asking or answering things, but yeah, I'll tell you. Like, there are like various chunked formats which are out there in the market. There are like commercial one as well as open source one, and I cannot speak for the commercial ones because they are more in the closed source space. But as for the chunked formats which are in the open source space, we try to maintain like feature parity with them and try to be more welcoming as to be like repulsive. As for the features and as for the edge as compared to these formats, I think yeah, it's like we are more open. Like we do things what you require, and we mostly take care of all the community feedback in order to proceed forward. Maybe that's not the best answer, but yeah, sorry.
Thank you. Moving on to the next question. Is it possible to use Zarr libraries / functionalities that work with NumPy arrays, or do they need to be modified in some ways to be compatible?
No, you can use it via NumPy. Yeah.
Yep, that's right. Next question. Is Zarr recommendable for data streaming to disk from, say, a camera source?
What source?
Camera source.
Okay, so it's really good because when I come to these conferences, I get to hear the use cases which we haven't seen. So I'm not aware of that. Like if this would be a good, I'm not aware if someone has used as a camera source to stream data to using Zarr. But I think like as for the safety, it's fine. Like yeah, the library is being used in production. We have like 24 million downloads a month. So I think you are safe. As for the intricacies and how to design it and how to like manage the pipeline, I'm not aware of that. So yeah.
Thank you. These were all the questions. Okay. Thank you again for your presentation.
Thank you.